Hello everyone, my name is Anna Prinkulova and this is my presentation on Kubernetes. So before I start with the Kubernetes, I'll give you a little overview of what the containers are, because Kubernetes itself is a container management platform. So what are containers? A container is a standard unit of a software that packages up a code and all its dependencies, so the applications run quickly and reliably from one computing environment to another. To make it easier to understand, you can compare it to a virtual machine. Although they're not the same, but they share some of the same principles. Let's look at the comparison picture. So the virtual machine side, you have the infrastructure. Just think of it right now as it's your laptop. Then you have your host operating system, might be anything from Windows, Mac to Linux. You have your hypervisor, and then you have your virtual machine guest operating system. You have your binaries and libraries, and on top of that, you can have your application. And if you want to have your application running isolated from each other on different virtual machines, you are going to have operating system bundled to each of your application. So on the side of the containers, you can see that you have your infrastructure, then you have your operating system, then you have the container engine, which will have all of the necessary binaries and libraries, and that's it. This is all you need to run your application on that. You might ask, what are the benefits of that? Well, since you don't have an operating system for each of your application, it saves you a whole lot of space, and the containers are very lightweight and portable. Also, it requires just a couple of seconds to spin it up. However, in a production environment, you need to manage the containers that run the applications and ensure that there is no downtime. For example, if a container goes down, another container needs to start. Wouldn't be that easier if this behavior was handled by a system? That's how Kubernetes Container Orchestration Platform comes in. What is Kubernetes? Kubernetes is a tool used to manage clusters of containerized applications. In computing, this process is often referred to as orchestration. Kubernetes automatically and perpetually monitors the clusters and makes adjustments to its components. It helps manage containers that run the applications and ensure that there is no downtime in the production environment. For example, if a container goes down, another container automatically takes its place without the end user ever noticing. Kubernetes is not only an orchestration system, it is a set of independent, interconnected control processes, and its role to continuously work on the current state and move processes in the desired direction. Kubernetes architecture and components. Kubernetes has a decentralized architecture that does not handle tasks sequentially. It functions based on a declarative model and implements the concept of a desired state. These steps illustrate the basics of Kubernetes process. An administrator creates and places the desired state of an application into a manifest file. The file is provided to Kubernetes API server using a CLI or UI. Kubernetes default command line tool is called kubectl. Kubernetes stores the file and application desired state in a database called Key Value Store, etcd. Kubernetes then implements the desired state of the relevant application within the cluster. Kubernetes continuously monitors the elements of the cluster to make sure that the current state of the application does not vary from the desired state. We will now explore the individual components of a standard Kubernetes cluster to understand the process in a greater detail. What is a master node in Kubernetes architecture? The Kubernetes master node receives input from CLI command line interface or UI user interface via an API. These are the commands you provide to Kubernetes. You define pods, replica sets, and services that you want Kubernetes to maintain. For example, which container image to use, which ports to expose, and how many pods replicas to run. You also provide the parameters of the desired state for the application running in that cluster. The key value store is also called etcd, is a database Kubernetes uses to back up all the cluster data. It stores the entire configuration in the state of the cluster. The master node requires etcd to retrieve parameters for the state of the nodes, pods, and containers. Controller. The role of the controller is to obtain the desired state of the API server. It checks the current state of the nodes it's tasked to control and determines if there are any differences and resolves them if any. Scheduler. A scheduler watches for the new requests coming from the API server and assigns them to the healthy nodes. It ranks the quality of the nodes and deploys pods to the best suited node. If there are no suitable nodes, the pods are put in a pending state until such a node appears. What is node in Kubernetes architecture? Worker nodes listen to the API server for the new work assignment. They execute work assignments and then report the results back to the Kubernetes master node. Kubelet. The kubelet runs on every node in the cluster. It is the principal Kubernetes agent. By installing Kubelet, the node's CPU, RAM, and storage become a part of a broader cluster. Container runtime. The container runtime pulls images from the container image registry. It starts and stops containers. A third-party software or plugin such as Docker usually performs this function. Kubeproxy. The kubeproxy makes sure that each node gets API address, implements local IP tables, and rules to handle routing and traffic load balancing. Pod. A pod is the smallest element of scheduling Kubernetes. Without it, a container cannot be part of a cluster. If you need to scale your app, you can only do it by adding or removing pods. The pod serves as a wrapper for a single container with the application code. Based on the availability of resources, the master schedules the pod on a specific node and coordinates with the container runtime to launch the container. In instances where the pod unexpectedly fails to perform tasks, Kubernetes does not attempt to fix them. Instead of it, it creates and starts a new pod on its place. This new pod is a replica, except for the DNS and IP address. This feature has had a profound impact on how developers design applications. Due to the flexible nature of Kubernetes architecture, applications no longer need to be tied on a particular instance of a pod. Instead, applications need to be designed so that entire new pod created everywhere within the cluster can seamlessly take its place. To assist with this process, Kubernetes uses services. Kubernetes services. Pods are not constant. One of the best features Kubernetes offers is that non-functioning pods get replaced by new ones automatically. However, these new pods have a different sets of IPs. It can lead to processing issues and IP churn as the IPs no longer match. If left unattended, this property would make pods highly unreliable. Services are introduced to provide reliable networking by bringing stable IP addresses and DNS names to the unstable world of pods. By controlling traffic coming and going to the pod, Kubernetes service provides a stable networking endpoint and fixed IPs, DNS, and ports. Through a service, any pod can be added or removed without any fear that basic network information would change in any way. How do Kubernetes services work? Pods are associated with the services through the key value pairs called labels and sectors. A service automatically discovers a new pod with the labels that match the selector. This process seamlessly adds new pods to the service and at the same time removes terminated pods from the cluster. For example, if a desired state includes 3 replicas of a pod and a node running 1 replica fails, the current state is reduced to 2 pods. Kubernetes observes that desired state is a 3 pods and then schedules 1 new replica to take the place of a failed pod and assign it to a new node of the cluster. The same would apply when updating or scaling the application by adding or removing pods. Once we update the desired state, the Kubernetes notices the disparity and adds or removes pods to match the manifest file. The Kubernetes control panel records, implements, and runs background reconciliation loops that continuously check if the environment matches user-defined requirements. Conclusion. The Kubernetes operates using a very simple model. We input how we would like our system to function. Kubernetes compares the desired state to the current state within the cluster. Its service then works to align the 2 states and achieve and maintain the desired state. You should now have a better understanding of Kubernetes architecture as well as what the containers are. Thank you.